All right, hello everybody. So we are now wrapping up skill number 3 for Unit 9 with level 4. Kind of putting everything together now. So first and foremost, okay, now that we've kind of done all these different types of factoring, as you always look for a GCF first. Okay, so this page is a perfect example of problems that look kind of different. But then if we're always in the habit of looking for a greatest common factor first, what is left is going to probably be something that we've seen before and we have a method for factoring. And so the goal here is to look for a GCF if possible, and then keep factoring as much as you can by using some of the methods that we've talked about. Okay, so for example, let's do the first one. So for the first one, I look for a GCF first, so I'm looking at 2b squared minus 2b. I know that 2 and b is going to be the GCF. And so what's left in the second factor, again, however you want to do it, either work backwards or divide, right? 2b squared divided by 2b, that's just b. And then 2b divided by itself is 1. So 2b times b minus 1. Now in this case, what we would do is look at the second part, and if we can factor, we would keep going. Unfortunately, in this case, there's nothing else we can do. Now, if this were a b squared minus 1, then we can do what we did in the previous section, which was difference of squares when we have a binomial. But in this case, that's it. Okay, so GCF, and that's the only thing we can do for number 1. But let's take a look at number 4 and see if that looks any different. Okay, so here we have a trinomial, and before we start thinking, okay, I'm going to do split the middle or the AC method and start multiplying, let's not do that quite yet. Let's do a GCF first if possible. So I'm looking at the 3, the 12, and the 9, and I know that 3 goes into all 3 of those. Since the leading term is negative, I'm going to use negative 3 as my GCF. And now I'm going to divide by negative 3 to all 3 of these to get a squared minus 4a plus 3. All right, and so GCF just kind of stays there for now, but our focus turns to the second set of the second factor. Okay, this looks like a trinomial, and it should factor. All we have to do is look at the last number. What multiplies to 3 but adds up to negative 4? Well, that's just going to be negative 3 and negative 1, right? Negative 3 times negative 1 is positive 3, and negative 3 times negative 1 is negative 4, and remember that these are both going to be a. Okay, and so there's our answer for number 4. GCF first, take a look at what's left. If you can break down or factor what's left, go ahead and do that using methods that we've talked about so far. And the GCF that you took out initially just comes down and stays in front. Okay, so let's do one more. Let's look at number 7. All right, so 9p squared, 30p, 24. Looks like 3, positive 3s is a GCF. And so that leaves you with 3p squared minus 10p plus 8. Okay, and And so now what's left over is the trinomial, but the leading coefficient here is 3. And so we're going to do the split the middle method, or the AC method, to keep breaking this down. Okay, and so I'm going to do that off to the side here. So this is a good review if you still need some work on it. Take the leading coefficient, the A value and the C value, multiply those together, you get 24. And now what multiplies to 24 but adds up to -10? You can think of all the combination, like 1 and 24, that's not going to work. 2 and 12, that's not going to work. 3 and 8 won't work. But 4 and 6, if we make both of these negative, I add them up, I get -10. I multiply them together. 2 negatives multiplied together give me a positive, so that's good. And so these are the numbers that we use to split the middle. Okay, so now what I would recommend doing is just kind of worry about this portion. So I'm going to rewrite 3p squared. I'm going to split the middle term using these two coefficients. So -4p minus 6p plus 8. And again, we factor by grouping. So looking at the first two terms, looks like there's a p that you can remove as the GCF, leaving 3p minus 4 as what's left over. Bring down whatever this sign is. If it were a plus, you bring it down. Here it's a minus, so you bring it down. And now between 6 and 8, you can take out a 2. And if you divide, everything by -2, you get 3p minus 4. That's what's left. And we got a match, okay? So we get 3p minus 4. And p minus 2, that goes in the second factor. And just don't forget, this is still there. So this first initial GCF that we took out, that needs to be part of your answer, okay? Sometimes I've seen that. It's a common mistake. People take out a GCF and then it just kind of disappears, but it should still be there when all is said and done. Because remember, in the end, if you were to multiply this out and then multiply it with 3, that's how you're going to get the original equation here, or the original trinomial. All right? So we've done a lot of factoring this unit so far. Now level 4 is just kind of putting everything together, but always, I can't emphasize this enough, look for a GCF first, okay? So when you see these, just in different contexts, okay, different equations, let's see if I can find some other ones here. So, like if I look at the previous page, page 89, let's say I didn't have any directions and it just said, factor. I would actually go through that process that we just went over. First, I look for a GCF. 5, 19, 12, okay, no GCF, so I don't have to worry about it. And then now I think, okay, I know for binomials, I do the difference of squares. And for trinomials, if this is a leading coefficient bigger than 1, we do the AC method or split the middle, okay? But so that's kind of the roadmap. There's a lot more factoring that comes up, and this is just the beginning. But factoring is a huge, huge part of algebra that carries with you into geometry, into algebra 2, into pre-calculus, into calculus, any other math class that you might take in high school or in college. Factoring is huge. I can't stress that enough. So work on it, keep practicing, and get as good as you can. All right? Have a good day.